Yeah, there's pressure there. Yeah. All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 34 is on the screen. Let's get started, please. Lock in. Second quarter is coming, starting today, so let's stay focused. Copy and go. All right, are we good? All right, so do me a favor, close those Chromebooks. You don't need them right now. Thank you, appreciate it. Yeah, I don't know what it is with screens. Some of you are hypnotized. Like what? Okay, y'all ready? All right, here we go. Being that it's Monday, I'm going to go over the warm-up completely, but I want to make sure that you understand each component of it because this is going to need, some of these skills you're going to need for what's coming up on the next concept, big concept that we're going to cover. All right, here we go. Starting with number one, to lowest term. Some of you are like, Mr. Q, this is so easy. I get it, but I want you to do it like this. Look up, please. To reduce this to lowest terms, you need to think of a number that can divide both numbers, which is 24 and 60. So the lowest one would be 2, is that correct? But what would be the greatest number that you can divide 24 and that you can divide 60? Think about it. The greatest number. 12. Be nice. 12, so this would be 12 times 2. And the other one is 12 times 5. So, why do we need it like that? Well, because now, since we have multiplication here and here, we can eliminate a giant 1. Do you guys see the giant 1? What is 12 divided by 12? 1. Is that correct? And that leaves us with 2/5. Next, let's go with this. Now, we did a video lesson last week to get you practice with this. Is that correct? So in case you forgot, here it goes. Let me break this down. The numerator can be broken down like this. 5 times t times t times t. Is that correct? The denominator, we have 2 times 5 times t times t plus 3 times 5 times t. Do you agree with that so far? The 10t squared is 2 times 5 times t times t. Yes. Plus, how about 15? 3 times 5 times t. Yes? All right, so question. Here it goes. What do these two and these two have in common? A 5, let's see. Do all of them have a 5? That one, that one, that one. Yes. What else do all of them have in common, Autumn, before you leave? 1t. 1t, 1t, 1t. So therefore, check this out. I'm gonna rewrite it over here so you guys can see it. So 5t, 5t, and 5t. So what does that leave us on the numerator? T to the second power. How about here? What's left here? 2t plus, how about here? 3. So if we put that in parentheses and we extract the 5t, I'm going to put it right here, 5t. Put this in parentheses, put the 5t on the side. Do you guys see the giant 1? What's our giant 1? The 5t. So put a giant 1. So therefore, our solution or our simplified rational is t squared over 2t plus 3. Okay? We're going to get into that today, by the way. FYI. Number 2. What number goes on top? Negative 18. What number goes underneath? 7. What two numbers multiplied give me negative 18 that when you add them give us positive 7? 9 and negative 2, is that correct? 9 times negative 2 is negative 18. 9 minus 2 is 7. So my factors for this one are x plus 9 and x minus 2. Notice I'm going a little bit faster now, yes? Okay? We got that from there. All right, let's go with this one. Is there a GCF? No, then However, now we have a number in the front. Reminder with those cell phones, mobile devices, put them away. I'm going to take them away. Fair warning? Yes? All right, good. What number goes on top? Remind your neighbor. 12. That is correct. What number goes underneath? 7. So, what two numbers multiplied give me 12 that when you add them give us 7? 4 times 3 or 3 times 4? Yes, so 3 and 4. However, what number is in the front? 6. So I said write that above this one and above that one. So, question. Leslie, how can we write this fraction in lowest terms? Can we divide by 3 top and bottom? Yeah, so it would be what? 2 over 1. So my factor is 2x plus 1. Next, how do we write this fraction in lowest terms? Can we divide by 2, top and bottom? So that would leave us with what? 3 over 2. So my factor is 3x plus 2. Are we doing? Yes? All right. Let's go to number 4. Evaluate when the domain is negative 1, 0, and 1, but you need to solve for y first. So for number 4, let me make some space here. It said solve for y. So add 12x, add 12x. We end up with negative 3y equals 12x minus 9. At the end, divide by negative 3, divide by negative 3. Y equals negative 4x, because 12x divided by negative 3 is negative 4x, yes? How about negative 9 divided by negative 3? Positive 3. And now we're going to evaluate according to what? For x, negative 1, 0, and 1. So here we go. Y equals negative 4 times blank plus 3. My first value, negative 1. So what is negative 4 times negative 1? 4 plus 3, 7. Do it again. Y equals negative 4 blank plus 3. Next value is 0. So negative 4 times 0 is 0 plus 3. That is 3. And last but not least, negative 4 blank plus 3. And that is a positive 1. So what is negative 4 times 1? Negative 4 plus 3. That's negative 1. Is it coming back? Yes? Yes, Missy Q. All right. Now, this is very similar to what we did, but we used what before? F of x. Is that correct? Same idea. All right. And number 5. Here we go. You're like, oh, Mr. Q, this is cake. I know, right? So what do we do when we have two fractions and we're adding, everyone? We need a what? A common denominator. But I want you to follow this process first. Look up, please. I want you to first factor the denominators. You're like, what do you mean, Mr. Q? Yeah. Two numbers that multiply to give me 15. That would be what? 3 times 5. How about two numbers that multiply to give us 6? 3 times 2. Bring down the 2, bring down the 5. Okay. So to find a common denominator, here we go. I want you to use this process. Question. What does this have that this one might need? What doesn't this one have that this one has? The 5, is that correct? So that means I need to multiply times 5, top and bottom. Question. What does this side need that this one has now? The 2, so we need to multiply times 2, top and bottom. So now we have a common denominator. What's our common denominator? Let's see. What is 2 times 3 times 5? 30. Is that 30 as well? Yes. So 30 and 30. What's on our numerator? What is 2 times 2? What is 5 times 5? Therefore, common denominator is 30. Then we just add the numerators, put a heart. Aww. So 4 plus 25, that's 29. How we doing? Good? All right. Now, should I get you guys to get your Chromebooks out, or do we do the work without Chromebooks? What do you think, Leo? He said without. Okay, so put away your Chromebooks, please. Leo for Presidente. Copy the agenda, please. Agenda, warm-up number 34 done. Today we're moving on to simplifying rational expressions. Home play sheet, practice A 10.3, all only. So make sure you get that home play and practice in. Now, I hope that you guys got plenty of practice with this, with your previous math class. I hope. But if not, I'm going to go over it step by step to make sure we got it. You know what I'm saying? So once again, if you have your colored pens, have them ready, because I'm going to break it down step by step. Get a Cornell note ready, please. You do need a Frayer model, which is that box over there. Make sure you get that in your notes. So once again, your home play for tonight is play sheet 10.3A. To access that, copy this code. Oh, my bad. Let me get the code. Give me a second. All right, here's the code. Code Q3GA9. Write that down, please. Q3GA9. That'll give you access to the home plate. However, in case it doesn't work, remind your neighbor where to go to find the home plate. Where to? YouTube, because watch. Because then I'm going to bring it up right now on the screen, and this is being recorded as we speak. And this is the home plate. No, just numbers 1 through 13. There they there they are. It shouldn't take you long. All right, so once again, make sure if your code doesn't work, go to YouTube, and this should come up on the video lesson of the day. Okay? All right. So, previous home play, had a great weekend. Yes, everybody recharged. All right. So, with that said, our objective for today, I can simplify rational expressions. I can simplify rational expressions. I can simplify rational expressions. So, if that's the objective, remind your neighbor by looking at it, what is the main concept for today? What are we moving on to? Main concept. Rational expressions, that is correct. And what are we going to do today? We're only going to simplify, that is correct. So I'm going to take it one step at a time, just in case some of you missed this last year. Maybe you fell asleep during class, or maybe you were on your Chromebook distracted. Not that you guys do that, I'm saying some of your friends. Yeah, you guys wouldn't do that. All right. I turned to look at Leo. He rolls his eyes. He's off. All right, rational expressions. Y'all ready? All right, write that in your Freire model, please. Rational expressions. What are they, Mr. Q? Well, rational expressions are algebraic expressions whose numerator and denominator are polynomials. Algebraic expressions whose numerators and denominators are polynomials. Rational expressions are algebraic expressions whose numerator and denominator are polynomials. Now, if they say numerator and denominator, they're implying that we are looking at what? Tell your neighbor, what are they implying? Fractions. Let's go. Love fractions. You guys love fractions, yeah? You're like, only a fraction of a time. See what I did there? A fraction of a time. Oh, yeah. I got this. I'm locked in. Quarter 2 locked in. We got this. It's going to go pretty quick, so stay focused. So, algebraic expressions whose numerator and denominator are polynomials. Now, I'm assuming you know what polynomials are. Polynomials are expressions that have many terms or many parts. And they have variables and a bunch of stuff like that. However, they don't have equal signs. That's why they're called what? Expressions. Examples. Write these down. Here goes a rational expression. 6 over g plus 4. This one, 2x plus 1 over x squared minus 15x. This one, 2x plus 6 over x squared plus 5x plus 6. Write those down, please. So, according to the definition, rational expressions are expressions that have numerators and denominators that have polynomials. So let's see. Do we have a numerator and denominator? Yes. Is there a polynomial here? Yes. There they are. How about here? Yes. Numerator, denominator? Yes. Polynomials? Yes. Okay. Look at them. These are rational expressions. If you were to say one word to someone, what would it be? What are rational expressions in one word? One word. Look at them. What are these called? Fractions. That is correct. Okay, let's go to non-examples. Look at these. Don't copy those yet. Tell your neighbor why this one's not a rational expression and why this one's not a rational expression. All right, let's go over here to the back. Carlos, why are these not rational expressions? They have equal signs, of course. These are equations. Expressions do not have equal signs. Expressions cannot be solved. They can only express values. Okay? So copy that down, please. So for the sake of time, hashtags, algebraic expression, it has to be an expression. Hashtag polynomials in the numerator denominator. And we said one more hashtag would be hashtag, one word was what? Fractions, yes. Hashtag fractions. Yes. Y'all ready? All right. So continue. Reminder on those cell phones, please. Quick definition. Look up. Don't copy this. You're like, oh, snap. What does that mean, Mr. Q? Well, that's the definition of fractions. So I'm going to break it down to you. Look up, please. Write your utensils down. Here goes. It says, quotient is the result of a division. What is a division, Mr. Q? Focus, please. A division is a fraction. A fraction, it's always a division, such as 3/4. Why is that division, Mr. Q? Because if we divide 3 by 4, it gives us 0.75. That's what we call a quotient. Yes? Say that again? No, I did that on purpose, see if you were paying attention. Fraction. My goodness. Anyways, all right, here it goes. according to the definition, look up. I'm going to break it down. Focus. To get a quotient, we need the set of all fractions known as m over n. Are you following so far? M over n. Such that m has to be a z. What is a d? A z, an integer, which is a whole number, including their opposites. N is also an integer. However, n cannot equal to what? So the denominator can never equal to what? 0. That's why we call that undefined whenever you guys cover that. Hold on. All right? So, today, my bad, let me go back. If we cannot have a value on the denominator to make it 0, that's what we call the excluded value. We're going to cover that today. Here's the process. Don't write these down. Today we're going to identify excluded values first. And it says write the denominator equal to 0 and solve. Step 2, factor completely the numerator and denominator using GCF and simplify identifying giant ones. So copy this one, example number 1. Copy that on your notes, please. Example 1, copy the instructions. Identify the excluded value, then simplify to lowest terms. Write that down, please, the whole thing. Then we have 2x over 2x plus 6. You don't write the steps. I'm going to leave them on the screen just so that we can use those as we move along. What happened? Yeah, the instructions. Example 1, instructions, and this rational expression. Copy that. The music, guys. And this is being recorded, okay? Now, here goes some a side note. Y'all ready? As we move along the school year, especially second quarter and third quarter, everyone pay attention to this one. Here it goes. As we move along for second quarter, third quarter, and the rest of the year, the rigor of the class is going to start increasing little by little. The rigor, I guess the difficulty level of the mathematics. Yes, the intelligence needed for this. All right. So what does that mean, Mr. Q? That means that some of you, pay attention to this part, that struggled in the past with mathematics, you have to be here 100%. What does that mean, Mr. Q? That means that you need to go to the restroom before you get to this class. Because check this out. I have some students, not going to mention any names, that they leave this class every day 5 to 7 minutes. Multiply that times 5 days. 7 minutes times 5, that's 35. That's almost an entire day missing. Now, is that going to help those people in case they're struggling with their mathematics? No. That's why be proactive and try to go to the restroom before you get here as much as possible. Even if you're a minute late, I'll allow for you to be a minute late. That's fine. But go to the restrooms like that. You're here 100%. That make sense? All right. So with that said, back to our regularly scheduled program. Step 1. First thing I want us to find is the excluded value. I'm going to use blue for that. And I'm going to write over here on the side EV. I want you to write EV in blue if you have it. Tell your neighbor what EV stands for. Some of your electric vehicle. Excluded value. What do we do to find the excluded value, Mr. Q? We take the denominator, set it equal to 0, and solve. So what is my denominator? 2x plus 6. Set that equal to 0, and solve it. Do we know how to solve that? Yes, Mr. Q. Minus 6 minus 6. 2x equals negative 6. Divide by 2, divide by 2. X equals negative 3. So my excluded value is negative 3. So what does that mean? Like your colleague said earlier, Scarlett, she said, oh, it's the number that cannot be included. That is correct. Check this out. If I was to substitute negative 3 here, don't write this down. Let me just show you. 2 times negative 3 plus 6. What is 2 times negative 3? Negative 6. What is negative 6 plus 6? Can the denominator be 0? No. According to the definition, we cannot have 0 in the denominator. That's why we cannot include this number whenever we get to the solving part. I'm just giving you this ahead of time. Yes, Scarlett? Right. Yes. Yeah, but we need to set it equal to 0 because these denominators are going to get a little bit more elaborate. All right. With that said, from 1 to 5, how comfortable are you with excluded value? Where are we at? Yeah, so we just take the denominator, set it equal to 0, and solve. Okay. So with that said, now let's go to simplify this. It says factor completely. Look at the numerator. Can we factor this anymore? No, just 2 times x. Denominator. Can we factor this one? Is there a GCF for these? What number divides these 2 terms? 2, and that leaves us with x plus 3. And somebody goes, how did you get that, Mr. Q? Well, the GCF was 2, so what is 2x divided by 2? That leaves us with x. What is 6 divided by 2? 6 divided by 2 is 3. All right. We're done with step 2. Last, identify any giant ones. Do you see any giant ones? Multiplication here and here, so the giant 1 is the 2 over 2. What does that leave us with? X over x plus 3. Now, before I move on, Mr. Q, why can't I do another giant 1 right here? Think about it. Don't say it out loud. Think about it. Why can't I take this away and only this? Well, it's not what, everyone? Multiplying. Here we were able, because there's multiplication here and here. What is going on here? Addition. That's why we cannot take that, and that's our simplified. Write it underneath. Simplified. And that's how your home plate is going to go. Yes. Multiplying top and bottom. Yeah. Because the bottom is being added. All right, let's do another one. Copy this one. Example number 2. Don't copy the instructions. Just copy the expression. 6x over 3x plus 9. 6x over 3x plus 9. To get started, I want you to find me the excluded value. I'll give you a head start. Go. All right, what'd you get for the excluded value, everyone? Negative 3. Hands if you got negative 3. So we took the denominator, 3x plus 9, set that equal to 0. Minus 9 minus 9. We end up with 3x equals negative 9 divided by 3. X equals negative 3. All right. Next, simplify. Factor the top and the bottom. Can we factor 6? Yes. What 2 numbers multiply to give me 6? 2 times 3 times x. Okay. How about the denominator? What's our GCF for the denominator? 3. So, 3x divided by 3, that leaves us with x. 9 divided by 3, that leaves us with 3. All right. So we have multiplication here. How about here and here? Tell your neighbor the giant 1. What's our giant 1? The 3's, yes. So that leaves us with, on the numerator, 2x. How about the denominator? X plus 3. That's it. This is what? Simplified. From 1 to 5, how comfortable are you with these so far? 5 fours, 3, 5 fours, 5 fours, okay. All right, let's do another one. Yes. Oh. Okay, once again, for some of you, this is review. Yes? All right, good. All right, example 1 super Q. Copy this one, please. Copy this. X squared over x squared minus 5x. We're going to do this one together because this one's a little bit more challenging, but that's okay. We got this. So, EV. All right, tell me what to write for excluded value, Miguel. The bottom, so tell me what to write. Minus 5x equals 0. That is correct. Okay. Now, does this look familiar? Yes, Mr. Q gave us some of this for practice. All right. It's not a trinomial, so I can't use Power Rangers, so what do? Is there a GCF here? What do both of these have in common? X. And that leaves us with x minus 5. All that equal to 0. Next, we said each of these equal to 0. Is that correct? X equal to 0. X minus 5 equal to 0. Let's solve. Oh, this one's already solved, Mr. Q. Yes. How about this one? Plus 5 plus 5, x equals 5. So now, how many excluded values do we have? 0 and 5. 2 of them. How are we doing? All right, so we're done with excluded values. Let's go to simplify. Factor completely. The numerator, how do we write the numerator in factored form? X times x. How about the denominator? What is our GCF for the denominator again? X. That leaves us with x minus 5. All right. Is there multiplication here? Yes. How about here? Yes. So, what's our giant 1? 1x. And that leaves us with x over x minus 5. Tell your neighbor why we can't do a giant 1 here again. Tell your neighbor why we can't do a giant 1 there. Why? Because there's what? Subtraction. Is that correct? We don't have multiplication. All right? From 1 to 5, how comfortable are you with that so far? Where are we at? Yeah, 4, 5, 3s. Okay. Do another one. Copy this one. Very similar to the one we just did. You should be able to do this one by yourself. Example 1 mega cube. Write that down. 2x over x squared plus 7x. 2x over x squared plus 7x. First, find the excluded value, very similar to the one we just did, and then simplify it. I'll give you a head start. Copy it. Yeah. All right, check with your neighbor, see what they got for the excluded value. They should be done by now. Excluded value. All right, excluded value. Good talk with your neighbor. What were my 2 numbers? Give us 1, Carlos. 0, he said. How about another one, German? -7. Hands if you got that. And how do we get that? We take the denominator, x squared plus 7x, set that equal to 0. GCF was x. That leaves us with x plus 7. From there, we set each one equal to 0, x equal to 0, x plus 7 equal to 0. Bless you. Solve. This one's already solved. -7 minus 7. X equals -7. All right. Simplify. Can we simplify this anymore? No, I'm just going to write it as 2 times x. GCF for this one is x. So, x squared divided by x leaves us with x. 7x divided by x, we eliminate that. That leaves us with 7. Right? What's my giant 1? Giant 1 is the x. Answer, 2 over x plus 7. Hands if you got that by yourself. All right. Go. I like these. Like, right? All right. Let's continue. Shall we crank it up a little bit? Oh, yes. Copy this one, please. Example 1, super duper cube. 6x squared minus 6x over 3x minus 3. I'll give you a head start. Find me the excluded value. See if you can simplify that. Go. See what you got. Hands if you got 1. That is correct. And again, you take the denominator. 3x minus 3, set that equal to 0. Plus 3 plus 3. 3x equals 3. Divide by 3. X equals 1. That's my excluded value. Let's simplify. Do this one together. Look up, please, so you're going to miss it. What divides the top two? What else? What else? How about 6? Yeah, 6. How about both of them have an x? Yes. All right, so if we took out 6x from here, that leaves us with x minus 6x divided by 6x, that is 1. Denominator. What's our GCF for the denominator? 3, and that leaves us with x minus 1. However, is the top completely factored out? How can we write 6? 2 times 3. Cross out the 6. 2 times 3. I know some of you are like, Mr. Q, I had it already like that. Yeah, but I'm just trying to show you guys step by step. All right. Next, what are my giant 1s? 1s. X minus 1. What else? And the 3 with a 3. So that leaves us with what, everyone? Oh, yeah, we got this. You're like, Mr. Q, give us a party tomorrow. From 1 to 5, I'll come to where you with us so far. Where are we at? 3, 4, 5, okay. Do another one. Let's see. We did one of these. Copy this one. Example 1, Star Wars Q. Copy that. X squared minus 4 over x squared plus 3x plus 2 on the denominator. All right, let's find the excluded value. Tell your neighbor what to write for the excluded value to get started. What do we write for the excluded value? Sarah, tell us what to write. That is correct. Equals 0. What does your brain want to do with this, everyone? What number goes on top? 2. What number goes underneath? 3. What two factors give us 2 when you add them give us 3? 2 and 1. So my factors are x plus 2, x plus 1, and all that equal to 0. So what do we do from there, everyone? Set each one of these equal to 0 and solve. So x equals what? -2. And this one, x equals what? -1. So my excluded values are -2, -1. All right. I want to finish this one because you're going to get one of these for home play. Look up. Let's factor this one. From the video lesson that you saw last week, let me pause the music. This is not a trinomial, but it's a subtraction, which means it's a difference. So what is square root of x squared? X times x. What is square root of 4? 2 and 2. Since it's a difference of squares, one of them has to be a positive, the other one has to be negative. Now, to factor this one, do we need to do the work again? No. What are my factors? X plus 2 and x plus 1. We already have it there. Yes? Giant 1. What's our giant 1, everyone? X plus 2. And that leaves us with x minus 2, x plus 1, and we are done. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye. Yeah, I'm time.